Next is starting of DC motors. So the starter circuits are not there in the GATE syllabus anymore. So we will not discuss the starter circuits, but you need to know why the starting of DC matters is an issue. Okay, why are we discussing it in the first place? What is so special about it? Okay, so we know that the back EMF EB is given by K into phi into omega, where K is the system, it will depend on the system parameters, it is a constant for a particular machine. Phi is the flux and omega is the speed in radian per second, angular speed. Okay. Now what will happen at the starting? At starting, what will be the speed? It will be 0. This means that the back EMF is also very small, negligible. Okay. Now when the back EMF is negligible, what will happen to the armature current? We know that the armature current is given by the terminal voltage minus the back EMF divided by the armature resistance. Now usually EB is in the range of Vt only. That means if it is 200 volt, then EB might be around 180 or 190 volt. Okay. So IA will be having not too much high, it will not be too much high. But let's say EB is now made to 0 at starting. Then the armature current is going to be very high when EB is equal to 0, which is what we are experiencing during the starting. Now when the armature current is very high, what will happen? It will damage the windings. This high armature current will damage the armature windings or the machine windings. Okay. So that is why this is not, obviously we don't want this. So that is why we are discussing about starting. This is the problem that we have to overcome. Now remember this expression, it is for shunt motor. But even if you take a series motor, it is not going to change much. IA will be equal to Vt minus EB minus drop across series winding. Okay, divided by RA. So this extra term is going to be there, drop across the series winding. So obviously, since the drop across series winding is also there, the problem is not as serious as it is in the series motor. Okay. So the shunt motor, the problem is more high current will flow. So you can write another point. The shunt motor is most affected by this large starting current. For series motor and compound motor, the effect is going to be slightly less as compared to the shunt motor. So now this problem, it can be solved by using low voltage at the starting. That means this Vt, whatever you have, terminal supply voltage that you are going to give, if you give less amount of voltage, okay, and then you slowly increase it, then the current will also slowly increase instead of drawing too much high current. Okay. And another method, this is one method. Methods to tackle high starting current. First one is reduced voltage during starting. And the second method is to use high resistance in the armature circuit during starting, and slowly you have to reduce it. So it should be reduced by the time normal speed is reached. Okay. Otherwise, what is going to happen under normal working conditions? If you are having a high resistance, then there will be unnecessary losses. Okay. So these are the two methods that are presently used to tackle the high starting currents. Okay.